हरि करना।
So far, we have seen containerization of small applications or monolithic applications. But just imagine you have 15 to 20 services and you have to run all services together so that you can host a very big application, or you have a lot of containers and all containers should communicate with each other to host your application. Or just imagine you have an uh, emote app, so where it has to communicate with various databases, MySQL, RabbitMQ, and various databases and another services also. So how it is possible? Because you will have 5 to 6 containers, maybe more than the 10 to 15 containers. And is it possible to is it possible to make make those containers communicate with each other and work in tandem, hand in hand with each other to run our application? Is it possible? How will it be done? That's what we are gonna look here. That is container orchestration. So we are gonna do that. That's why I call this as a Docker in production, in a real production. So Docker, to put in real production, you require a container orchestration tool so that you can deploy, you can put the very big applications in production using Docker containers. So we have seen discovering Docker and exploring Docker inside the engine room, Docker architecture, and day-to-day Docker, that's volume persistency and configuration management and putting your house in order and housekeeping. And we have seen the difference between entry point and CMD. Now we will be jumping to the Docker or container orchestration. So let's begin. Container orchestration Container orchestration tool is used to manage multiple Docker containers. Let's jump into it. So the orchestration tools in the Docker ecosystem that we're going to look here, the technology Docker is built on and has existed for a while in different forms. But Docker is the solution that is managed to grab the interest of the technology industry. This puts Docker in an enviable position. The mind share did the initial job of kickstarting an ecosystem of tools which became a self perpetuating cycle of people being drawn into the ecosystem and contributing back to it. So this is particularly evident when it comes to orchestration after seeing a list of company names with offerings in this space. You would be forgotten for thinking that everyone has their own opinion on how to do things and has developed their own tools. Although the ecosystem is a huge strength of Docker, the sheer quantity of possible orchestration tools can be overwhelming to novices and veterans alike. Now, I will take you on a tour through some of the most notable tools available and give you a feel for the high level offerings so you are better informed when it comes to evaluating what you want a framework to do for you. There are many ways of arranging the family trees of the orchestration tools that you are seeing on the screen. But this slide shows you some of the tools we are familiar with, and specifically I am familiar with. Not we, I am familiar with. I am familiar with it, but most of the tools you might also have heard. But this is comes from my bias. Okay, this family tree that I have made, this has come from my bias. So in my life, whatever I've seen a lot, so those tools I have included. Okay, you may find a lot of other tools, but if you want to explore more, I would suggest you to just do more research on that. But this is based on my bias. I made this family tree of orchestration tools. So at the root of the tree, we have Docker run, the most common way to start a container. Docker run. Okay, that's at the root of the tree. Then on the left side are the tools that treat groups of containers as a single entity. You just see here: Compose, Kubernetes, Console, it's etcd and Zookeeper. They treat groups of containers as a single entity. I will come into that. I will come into that. What is that? It's a cluster. It's called cluster. And the middle shows the tools focused on managing containers under the umbrella of systemd and service files. That is here, systemd and then fleet. Okay, these focused on managing containers under the umbrella of systemd systemd and service files, because this is services basically based on this systemd services. So, and all those tools which uses the systemd service, they are I put them in a separate branch. Then we have finally the last tree or last branch of our orchestration tool tree is it treats individual containers as that's it. We have Helios, Swarm and Mesos. So it's gonna deal with individual container, and it will consider it as an individual container only, and it will orchestrate based on individual container. So here we have seen three types. One, the leftmost, Compose, Kubernetes, etcd, Zookeeper, who treats groups of containers as a single entity. At the center we have, this is based on the system md, and then on a rightmost we have Helios, Swarm and Mesos, which who deals these entities, these containers as like that, just like that. Okay, so as you move down the branches, the tools end up doing more for you, be it working across multiple hosts or taking the tedium of manual container deployment away from you. Here you could say that etcd and Zookeeper, these are all powerful. So as you move down the tree, and you will note two seemingly isolated areas on the diagram, that's Mesos and Console etcd Zookeeper. This Mesos and etcd Zookeeper. Mesos is an interesting case. It's an interesting case. It existed before Docker, and the support it has for Docker is an added feature rather than core functionality. It works very well though, and should be evaluated carefully. if only to see what features from it you might want in other tools. By contrast, console, it consists of etcd and zookeeper. So etcd and zookeeper aren't orchestration tools at all. Instead, they provide the important complement to orchestration service discovery. So this is all about an orchestration tools and their family, and then their family tree and their functionality, their purpose, and how they does it. So now we will start slow by turning our gaze inwards into a single computer first. Then we will look into multiple computers with connecting multiple computers or multiple hosts and running a cluster with multiple hosts. Here I said multiple computer means it's a host. So we will begin with looking into a single computer, a single host. Then we will go for we'll create a cluster with multiple computer. Why to wait? Let's jump into the action. Keep watching. More fun is loading.